IEEE 802.22 WRAN real-time and non-real-time traffic delay. Here I'm giving some outline to the presentation, what we will present, what we will show. I will start with the motivation to show what is interesting in this work and why we did this job, and I will give also some background for the cognitive radio and about spectrum sensing and why we are talking about spectrum sensing. And my thesis partner will continue about the model and showing some mathematical analysis equations and how we derive the equations that we used for the showing for getting the results, and also the conclusion and some future work. So what was interesting here in this job, we wanted to reduce some delay that happened in the cognitive radio network, and always the time it's very crucial factor, and it's been always something very interesting for the researchers to minimize this delay. Here it's a very common figure that we are seeing in many resources, and here I can show that we are working in the very outer circle in the WRAN, the Wireless Regional Area Network, and this shows the IEEE standards, and our standard is this there. It's 802.22, and it can show that it has the range up till 10 till 30 kilometer, and it shows here also before the Bluetooth and Wi-Fi, WiMAX, with the different ranges. Here we cited one of the most common definitions of the cognitive radio, and this definition it's given by Simon Haykins. It's it's an intelligent wireless communication system that's aware of its surrounding environment, i.e. the outside world, and uses the methodology understanding by building to learn from the environment and adapts its internal states to statistical variations in the incoming radio frequency stimuli by making corresponding changes in certain operating parameters. Example, transmit power, carrier frequency, and modulation strategy in real time with two parameter objectives in mind. So in other words, here we can show in the architecture that we have horizontally the primary users, and horizontally is the cognitive radio, and here you can see that how is the primary user use some of the spectrum from the cognitive radio, how it uses some of the spectrum from the primary user, and here it's without the infrastructure, it means without the base station, and here with the infrastructure it's with the base station, because here it's with the ad hoc access. Yes, and in this slide we are showing that it's for each network. It's as I said in the previous slide, the primary user and the primary base station, and for the cognitive radio network it's also we have the cognitive radio user and the cognitive radio base station. So before showing the stages of the sensing, I want to say why we are talking about the sensing. It's as I mentioned in the previous slide. It's about the motivation that it's the time is the crucial factor that we are concerned with. So because of this sensing, we have this delay happening in the cognitive radio, because the secondary user or the cognitive radio user, like when it wants to use some spectrum for the primary user, it should make the sensing first. So this sensing will make this delay, and there are some stages for this sensing. Like we have the fast sensing and the fine sensing. The fast sensing we call it the energy detection, and for fine sensing we call it the feature detection. And the two stages we call it TSS, the two-stage sensing. And we can see from the equation that we have for the whole sensing time, it's for the whole frame, it's n times fs. So it is the fs, it is the size of the frame, and n is a positive integer, so for the whole frame. Here in this flow chart, we are showing that how the sensing happening. For example, like if we have the fast sensing in the beginning, we will have some alarm. So sometimes this alarm can be false. Like if the energy is greater than the threshold, it means that the channel is occupied. So it means that the primary user, the secondary user will not be able to use the spectrum. But sometimes this energy, it can be, as I said, it's false alarm. Like it means if it has some noise, so the energy can be greater than the threshold. So that's why we, in our proposed solution, we make many we make many alarms, not only one, because this alarm, it can be because of the noise, not because of the signal. So otherwise it will be starting the fine sensing. And also the same case, if the energy is greater than threshold, it means also the channel is occupied. Otherwise the channel will be empty, and in this case it will be ready for the secondary user to use this space. And here we showed like some methods of the sensing. They are the most common one. It's like the energy detection, the cyclostationary sensing, and the sensing based on waveform, and match vector. And now I will hand the slides to my thesis partner to show the model and some results.
Hey, thank you very much.
Thank you.
Okay, so let's start with the opposition.
Goes correct. I think you heard about the OSI model?
Yes, yes.
Okay, could you just explain me where this falls, which it falls? Can you give me an explanation how it's concerned with OSI, if it is?
Okay, like which layer or something.
Yes, it's mostly the work done in the physical and the link link layers, like the last two. We can show you a figure in the thesis in the report, like it's we have it. So I think they are here.
Today's date.
States.
You go to 12, 20, almost at the end. That's
This one,
yeah.
okay.
And reports.
Exactly.
This
Right.
one, okay.
I think chapter 2 maybe.
Yeah, this one. We are just trying to show you the figure from the chapter, so it will be more. Yeah, this one. Yes. If you see that the last two layers, that we have the link layer and the physical layer. Yes, like you can see like the spectrum sensing, it's mostly done in the physical layer, whereas for the spectrum sharing, it's done with the link layer. But it's also there are some sharings between both of them. It's because we already mentioned, Naufal mentioned about the the type of the sensing, the type of the presentation. Here we can see it's as well in the slides before, the type of the delay, like you have the Q sensing and the cumulative transmission. So because of the Q delay and the cumulative transmission delay, so the link layer will be there. Yes, so it's not only the physical.
Oh, okay.
Yeah.
Oh, that's thank you.
Thank you.
Okay,
Thank you.
thank you very much. We will have some audience questions.
What do you mean by model architecture as a title?
Yeah, the architecture here, like it's we mean that is because they are the main concepts of it's for our work, for our design. So like also like they are the proposed solutions for the work. So like we said here, multiple fast sensing, like many fast, like it's not only one sensing, and fine sensing of non-real time users. So like we consider them as architecture for our work. So that's why we call it. Otherwise, it's not like figures or something. So we figure it in this way, like architecture.
Okay.
Yeah.
I have one question.
Yes.
What is your is this your own work completely, or
Yeah.
is it based on
Yeah.
what is your work basically, and what
Yeah,
is
actually, maybe you can see that there has been some research, like some people use data rate reservation to get low delay, and some people, because it's a new topic, so some people use multiple fast sensing. Another paper was done by performing fine sensing. We combine the three things together and derive the formulas in order that we get a much lower delay than everyone separate. And
Okay.
so,
So it's the whole idea is basically your own.
yeah, it was
Like
actually it was by coincidence. We are reading topics. I read one like this one, then
Like when we mix these solutions all together, we could see we get even less delay.
Exactly.
Yeah, so why not we also like a new idea, like making less delay,
Yeah.
like together, all together.
Okay. It's very nice work. Yeah.
Thank you so much.
Yeah, I think we will conclude this part of the presentation. Thank you very much.